Okay, section 6.2 is the natural base E. So remember, the history of math is marked by the discovery of special numbers. For example, we had I from this semester, and we had pi from a long time ago. So if you think about it, pi is the circumference of a circle over the diameter of a circle, and it doesn't matter how big your can is or whatever you're measuring, it should always be about 3.14159, et cetera, et cetera, et cetera. Okay? So the next real important number in math is E. And it's known as Euler's number, and it is defined as x approaches positive infinity, y equals 1 plus 1 over x, and that approaches E. So just real quick here, if I did something like that, it would approach this E, okay? And again, that would kind of have an asymptote there. And E is approximately 2.7. Oh, sorry, I have a comma there. I didn't realize that. 2.71828. And like pi is an irrational number, it never ends and it never repeats. So this one right here, again, there would be 1, there would be 2, and this would be 2.718, et cetera, et cetera, et cetera. It is used so much that it has its own key. On most calculators, I noticed on Desmos, we're going to have to do a little something different, but it does follow the same properties as exponents. So, example 1, simplify each expression. So E is equal to, A is E squared times e to the 9th. Well, remember, if the bases are the same, then all I have to do is add the exponents, so that would be 2 plus 9, and that would be e to the 11th. Okay, so let's go to our Desmos calculator here, and if you are using the 1, okay, let me get rid of both of them, I guess. So if you're using this one here on your computer, you're going to have to go to the letters, and you're going to have to put E, and then we can go back here and we can do squared, and then we're going to do times, and then again E to the 9th. So then we're going to have to go here and go to this A raised to the B power and put 9 there. And notice we have 59,874. So what it's saying is you can always check, all right, especially when it's just real numbers, no x's or anything like that. And so on this one here, if we go E and go to the 11th, oops, not sub, what did I do there? Up above, and as you can see, they are the same, okay? So that's one of the things we're looking at, okay? On the second one, you have 25e to the 13th over 5e to the 12th. So remember, on this one here, I'm going to take the numbers and I'm going to divide them. So 25 divided by 5 would be 5, so that would be on top. And then our rule is when the bases are the same and I'm dividing, I subtract the exponents. And we know that 13 minus 12 is 1. We usually don't put to the first power there, so we would just put E. And then on the last one here, for this, we have C is E is 2 times E raised to the negative 3x to the 5th power. So on this one here, we can write that as, again, remember, and here's the big mistake. I always see people just leaving it as a 2. But remember, that 2 is actually being raised to the 5th power 2. And then we have E to the negative 3x times 5, because it's a power raised to a power. So if you think about it, that 2 is raised to the first power, so it's 1 times 5. So on this one here, we would have 2 to the 5th is 32. And then we'll have e to the negative 15x. But remember, we cannot have a negative exponent. So we would take that and put the e raised to the negative 15x power down below and make it positive. Okay? All right, so a function of the form y is equal to a times e raised to the rt is a natural base exponential function. So when a is greater than 0, r is greater than 0, we have exponential growth. When a is greater than 0 and r is less than 0, we have exponential decay. So on this first two that we're going to graph here, you're going to say, again, your a in each of these would be 1, all right? So all we have to worry about is what our graph looks like. So on this one here, we're going to take our x and our y, and remember, I've been taking -2, -1, 0, 1, and 2 for you. Now remember, this here would be e raised to the negative second power. Now you could plug that into your calculator just like that, and you'll get approximately 1.14 on e to the negative first. You're going to get approximately 0.37. At 0, again, e raised to the 0 power, we know that will be 1. E raised to the first power, we just said it's approximately 2.71. So let's just say 2.7. And then e squared, if we plug that in our calculator and round, we'll get 7.4. Okay? So again, let's go ahead and graph that. So there's our easy one. Let's see, 0.37, we know that's going to be less than 5. And we're going to have something like that, right? And then we said it's 2.7, so there's 2, 3, so 2.7 will be somewhere like here, and then e squared would be 7.4. So that's going to be where, let's see. So 7's right there. Notice I had to zoom in because I couldn't see it very well. So it's going to be 7.4, so about right there. And again, just like yesterday, the x-axis is going to be an asymptote. We'll find out in a couple days that we can move that up and down. We'll still have an asymptote. All right? I think on the homework, it is going to ask you to tell me what the domain and the range is. So the domain on this one here, again, where we can use all x values, so we know it's going to be from negative infinity to positive infinity, or all real numbers. And the range, we know, is going to be y is greater than 0, or again, using the function notation that the colleges want us to do, you would say it would be 0 to infinity. Okay, now the same thing on the next one here. Okay, again, now we have a negative x power. So on that one, we would expect it to be going down. We would expect negative, a negative times a negative is a positive, right? So that would be here for this one here. We would write it as e raised to the -2 power, or e squared. Well, that's just 7.4. So if you kind of notice, what we're doing here is these ones are actually switching from the one we just did, except for, again, anything raised to 0 power is 1. So this would be 0.37. This would be 0.14. And it's, again, what we would expect. So 7.4 would be about here. 2.7, excuse me. Put that in the wrong spot. Would be 2.7 for -1. So 1, 2, 1. And again, the x-axis is still acting as your asymptote. All right? So you're going to have an opportunity to graph. And you can always graph these and put them in the calculator and see what you can get. All right? On a lot of your calculators, you do have an E button. All right? I just showed you on Desmos. If you're using the Desmos on here, you can't really see the E. Okay? So you're going to have to type it in. But look at your calculator. You might have an E button somewhere. Okay, so those were the ones that we have. But again, we have a couple other ones here that are important. So you can rewrite natural base exponential functions to find percentage rates of change, which we just did yesterday. Okay, so rewrite the following in y is equal to a 1 plus or minus r raised to the t power form and state the rate of change. So the example I gave you is y is equal to 2 times e raised to the 3/10 t. So there is a decimal right in front of that. So you can rewrite this then as y is equal to, again, what we're trying to see here, ladies and gentlemen, is try to get the number with the e. So we can write this as 0.3 raised to the t power, because remember, a power raised to power, we're multiplying, right? So if I write that, then we can see that y is equal to 2 times 1.35 raised to the t power. All right. So to have it like this, well, we can see that our a is 2 in our case. So what we have here is this is what we're going to look at. Well, is that 1 plus r or 1 minus r? And you would tell me, well, that one is 1 plus r. So if I rewrote it like that, I would have 1 plus 0.35 raised to the t power. Okay. So this here is our rate of change. Okay. And we need to make it a change to a percent. So on that one there, we would have 35%. Okay. And then you have learned that the balance of account yesterday, earning compound interest, is given by A is equal to P 1 plus R divided by N raised to the NT power. So as the frequency N of compounding approaches positive infinity, we can say that the interest is compounded continuously and is given by A is equal to P, which is the principal, times E raised to the R, which is your rate, as a decimal, and T, which is your time in years. So what we're going to do here is we're going to look at an example here where we're going to kind of see what happens here. All right, so let's see. Carl plans to invest $1,000 in an account that pays 6% interest. Find the balance after 10 years when the interest is compounded quarterly. So if it's compounded quarterly, remember, we would say that N is equal to 4. And let's see, we're saying 6%. So we're going to change that to a decimal. So that would be 0.06. And remember, since it's quarterly, we're looking at this one here, all right, where our N is equal to 4. So we're going to say A is equal to 1,000 times 1 plus 0.06 raised to the fourth, divided by 4 times, what is it? 4 times how many years? 10 years. Okay. And if we work that out, we'll get $1,814.02. Okay. Monthly, your N would equal 12. Weekly, your N would equal 52. And daily, well, there's 365 days in a year. Okay. So again, we would plug in the same thing here. I'll do it one more time, but then I'll just give you the answers because, of course, you don't want me to keep writing down this every single time and waste a lot of your time when you can just be plugging it in yourself. Okay, remember this time our n is equal to 12. And then we would have 12 times, again, it's 10 years. And we would see on this one here, we would get $1,819.04. Okay, now if we're going to keep doing that, I'm just going to tell you the next two. So, I mean, what we do, we ended up making about $5 more in there, $5.02. I guess that's okay. Let's see, when we do weekly, we're going to take, and if I plug it in, I would get $1,821.49. If I do it daily, I would get $1,822.03. So as you notice, it's raising just a little bit more, All right, again, on those two, I would still use the same formula as I did for A and B, but when we're talking continuously, then I have to use E. So I would have A is equal to, again, our principal, which is 1,000. Then we'll have E raised to the 0.06. That's my R, right? So we're using this formula here now. And our T is still 10. So again, plugging that into your calculator on this one here, you would get $1,822.12. So notice that's only what? 9 cents more over 10 years than if it's compounded daily. So remember, you think, oh, continuously I'm going to make a lot of money. But remember, it kind of, like we just talked about earlier, we know that it's going up, and it has to eventually flatten out. Because, a bank has to make money somewhere. They're not just going to say, oh, here, let this person make all this money. So even when they say compounded continuously, you can see it's going to reach a flattening part, which in this case was $1,822.12. All right, so that was a good little lesson. Usually when you're in class, I have us all do one of the others, so it makes it go a little faster. All right, so thank you, ladies and gentlemen. Do your homework.